Okay, let's talk about polynomials. A polynomial can be a number, a variable with a whole number exponent, or a number times one or more variables whose exponents are whole numbers. The variable cannot be in the denominator, between absolute value symbols, and beneath a radical. So here are some examples of polynomials. This is a number. This is a fraction, a number and a variable, a number times one or more variables, a number times one or more variables, 0 and y. Now, when you have one term, this is called a monomial, mono meaning one. When you have two terms, this is called a binomial, bi meaning two. When you have three terms, this is a trinomial, tri meaning three. The coefficient is the number in front of the variable. 8x to the fifth, the coefficient is 8. 15. Now, when you have a number is its own coefficient. And so when we add and subtract polynomials, it's like adding and subtracting like terms. And we leave the answer in descending order of the exponent. And when you add and subtract polynomials, the exponents cannot increase. Now, we will see this later on when we add and subtract polynomials. So the first thing we want to do is just look at multiplying. We've done this before. 2 times 3y. So this is 2 times 3 gives me 6y. Now here is the first rule of multiplying. So when we're multiplying with exponents, keep, and the bases are alike, so the bases have to be alike. Keep the base and add the exponents. When multiplying with exponents and the bases are alike, keep the base and add the exponents. So the bases are alike here, so we keep the base, we add the exponents. 2 plus 1 gives me 3. Okay, and so this would be x cubed, and then I want you to put a 3 there. All right, let's look at this. This is multiplication. Okay, and so we multiply the numbers. You can rearrange these. With multiplication, you can rearrange and put the numbers together, put the variables together like this. Let me go through and check it. I got the 2, 3, and 5. 2, 3, 5. I got x to the first, x squared. Y to the ninth, y to the fourth. So I have all of these in order. I multiply the numbers. That's 30. Keep the base, add the exponents, x cubed. Keep the base, add the exponent, 13. 30x cubed, y to the 13th. Now, let's look at the power to a power rule. This is the power to a power. So before I do the rule, let's just take a look at this. 3n cubed squared means 3n cubed times 3n cubed. So that's 3 times 3 times n cubed times n cubed. 3 times 3 is 9. Keep the base, add the exponents. Okay? So this is 9n to the 6. So what is the product rule? So the product rule says when multiplying, so when raising an exponent, to a power, we multiply the exponents. So therefore, I could have used the power to a power rule here. So let's take a look at this. Now, when you have numbers, you want to be extra careful. Make sure you put an exponent there. That's 1. And then you say exponent times exponent. That's 2. Exponent times exponent. That's 6. So 3 squared is 3 times 3, which is 9, not 3 times 2, which is 6. 9n to the 6. All right, let's look at dividing. When dividing with exponents and the bases are alike, keep the base and subtract where the higher exponent is. So the higher exponent is in the denominator. So this is 7 minus 3. Now you can't have a headless fraction, so that's a 1 up there. 1 over x to the 4th. Now let's look at the long way. The long way is to write out all these x's. So 1, 2, 3, 4, 5, 6, 7. This and this cancel, this and this cancel, this and this cancel. Now, when everything cancels with multiplication, it's a 1 up here. And then 1, 2, 3, 4. X to the 4th. All right, let's look at this one. All right, we are dividing. The bases are alike. We keep the base and subtract where the higher exponent is. This is 7, that's 4. So 7 minus 4. B cubed, B squared. 3 minus 2. B to the first over A cubed. The long way, 4 A's, 3 B's, 7 A's, 1, 2, 3, 4, 5, 6, 7, 1, 2. A and A, A and A, A and A, A and A. So I have 3 A's left here, B and B, B and B, 1 B on top. Now, let's talk about negative exponents. So a negative exponent means reciprocal, okay? So let's talk about reciprocal. So if this is 4/5, so the reciprocal is equal to 5/4. That's what reciprocal means. You have to turn it over. So let's say that we have just the number 7. I need to put a 1 here to get the reciprocal is 1/7. Let's say that we have 1/3. The reciprocal would be 3/1, which is 3. Okay, so reciprocal means that we're going to flip this. So let's take a look at these. All right, so this is B -2. I need to put a 1 here. And this negative means reciprocal, okay? And so that means I flip this, and once I get the reciprocal, the exponent is no longer negative. So this says the reciprocal of b over 1, which is going to be 1 over b, and then it is squared. And let's do it like this. This says the reciprocal of a over 1, which is 1 over a, and then the exponent is positive. Well, this is 1 over a to the 4th. This says the reciprocal of c, so this is 1 over c, and once I get the reciprocal, it's cubed. 1 cubed over c cubed, 1 over c cubed. Okay? Now, let's look at this. This says the reciprocal of this fraction. Well, that's going to be y over x. And once I get the reciprocal, the exponent is now positive. And then we could, put ones here. Y cubed x cubed. This negative exponent means reciprocal, b and a. The exponent is now positive. Put a 1 here and a 1 here. Power to a power. Power to a power. Now, okay, we want to be careful here, okay, and take these individually. X to the minus 1, it's in the numerator, so I need to bring it down here. This is in the denominator, it means reciprocal, and there are only two places you can put a number, in the numerator and denominator. So if this means reciprocal, that means that goes up, okay? Let's take a look at these. This is negative, it means reciprocal, this needs to come down. This is negative, it means reciprocal, that needs to go up. This is negative, that means reciprocal, that needs to go up. Now, notice what we have here. We have division and we have negative exponents. Now, when we were dividing with exponents and the bases are alike, we keep the base and subtract where the higher exponent is located. What I recommend that you do so that you will not make a lot of mistakes, I recommend you go through and rewrite all of your negative exponents and then use the division rule. So let's just sort of with a checklist. Start here. This is a negative exponent. It needs to move down. This has a positive exponent. It stays up here. This has a negative exponent. It needs to move down. So we have taken care of the numerator. Let's go to the denominator. This is x to the 6th. The exponent is positive. It stays where it is. So I'm going to put it in front of that x. This is a negative exponent. It needs to move up. This is a positive exponent. It needs to stay here. So let's see, what do we have? We have y cubed, y to the 7th, x to the 6th, x squared, z to the 4th, z to the 8th. Okay? Now, after we have done the negative exponents, we want to use the product rule. So you got your negative exponents. Now you have to use the product rule. So this is y to the 10th, x to the 8th, z to the 12th. Now, after you use the product rule, then you want to use your quotient rule. Now, I don't have anything to subtract. See, to use the quotient rule, I'll have to have a y here and a y here. So I don't have anything to do. So I'm going to leave that as it is. Rewrite your negative exponents, do the product rule, do your quotient rule. Now this one is a little different because notice that we have all this on the inside and then we have an exponent on the outside. Again, I recommend you clean up this inside and then we'll do this product rule. Okay? So Okay. X minus 2, y cubed, z minus 5, x to the 7th, y to the 5th, z to the minus 8th, cubed. And let me make sure I have that correct. Okay. All right, so we're going to clean up this inside. We're not going to bother that yet. This is a negative exponent. It needs to move down. This is a positive exponent. It stays where it is. This is a negative exponent. It needs to move down. So I have taken care of the numerator. Let's go to the denominator. This is a positive exponent. It needs to stay where it is. This is positive. It stays. And this is negative, so it needs to move up. Okay. We are still trying to clean up this inside. All right, so in the numerator, I have y cubed z to the 8th, x squared, x to the 7th, z to the 5th, y to the 5th. All right, let's clean this inside up. We have rewritten the negative exponents. Now we want to use our multiplication rule, which is here. This is a lengthy problem. All right, now that we have used the multiplication rule, we want to use our division rule. And division says that when dividing with exponents, the bases are alike, keep the base and subtract where the higher exponent is. So this is y cubed, y to the 5th. This is higher, so I'm going to subtract down here. 5 minus 3 gives me 2. So I've taken care of that. Z to the 8th, z to the 5th. 8 is higher than 5, so I subtract in the numerator. 8 minus 5 gives me 3. So I've taken care of that z to the 8th, that z to the 5th, x to the 9th stay. Okay. We have cleaned up the inside using the product rule and the quotient rule, and now I'm going to use the power to a power rule. 3 times 3 gives me 9. 9 times 3 gives me 27. 2 times 3 gives me 6. And so this is our answer. So let's summarize what we did. Okay, so what did we do? One, we rewrote negative exponents. In our quotient. Okay, that's what we did. Number 2, we used the product rule on the inside of that parenthesis. Three, we used the quotient rule. on the inside of the parenthesis. And then finally, we use the product rule for the outside exponent. And it says it here, rewrite with no exponents, with no negative on the inside. Simplify using the rule for multiplying with exponents. Simplify using the rule for dividing with exponents. Simplify using rules for negative exponents. This is for the outside exponent if there is one. And then remove the outside exponent by using the rule for power to a power. So let's tackle this problem. This time the outside exponent is negative. So we're going to rewrite with no negatives on the inside. X to the fourth comes down. Y to the seventh stays. Z to the fifth comes down. X cubed stays. Y to the fifth stays. Z to the 11th goes up. Okay. All right, so we don't have any negatives on the inside. Now let's use the rule for multiplying with exponents. On the top, we don't have anything. In the denominator, we do x cubed times x to the fourth is x to the seventh, z to the fifth, y to the fifth. All right, let's use the rule for dividing with exponents. Okay, this is y, this is y. So the bases are alike. We keep the base, subtract where the higher exponent is. 7 minus 5 is 2 in the numerator. All right, let's go to z. Z to the 11th over z to the 5th. 11 is higher than 5. 11 minus 5 is 6 in the numerator. And x to the 7th stays here. So we got that. Now, I have a negative exponent on the outside. So that means reciprocal. So that means this becomes x to the 7th, y squared, z to the 6th, and the exponent is positive. And now I remove the outside exponent by using the power to the power rule. This is good stuff. 7 times 2 gives me 14. 2 times 2 gives me 4. 6 times 2 gives me 12. So this is using negative exponents. A lot of work. All right, and so we already know that the negative exponent means reciprocal. And so we just end up flip-flopping y to the 7th, y to the 9th, and then we subtract where the higher exponent is. 9 minus 7 gives me 2, y to the 2nd. Now, it might be some of you to say, I might not want to do all that work. I do recommend that you do this so that you don't encounter a lot of negatives. But if you just want to say, I'm going to subtract where the higher exponent is without changing these to positive, negative 7 is higher than negative 9. So let me show you what it looks like. So you're going to have negative 7 minus a negative 9. So the question is, would you rather do this, or would you rather just move them up, move them down, and then subtract? I think this is better for you because you do have the chance of making more mistakes. These double negatives means a plus, and then you have adding sign numbers. So you have more chances of making mistakes if you just use it in one fell swoop. I'm going to subtract where the higher exponent is. So the question is, what do you feel more comfortable with? This or this? All right, let's take a look at this problem. Now, all of this is multiplying, okay? So this is 2. This is w to the minus 5, so it needs to come down. This is x. This is times 4. Now, when we're multiplying with numbers, we do have to put the multiplication symbol in between. With variables, we don't have to. X to the minus 1, z to the minus 8th, 2, and then v to the 7th. So let's see what we have on top. That's going to be 16x v to the 5th. And this is x w to the 13th v to the 7th. X and x will cancel. And v to the 5th, v, okay. So this is 16 w to the 13th. 7 minus 5 gives me 2. So 16 over w 13th v squared. Now, some of you might say, I just want to use the product rule. Product rule says keep the base, add the exponents. I mean, you could do that. All right, so let's do the numbers. 16. And if you're going to use the product rule, this is w. So you just keep the base, add the exponents. Keep the base, add the exponents. Keep the base, add the exponents. Okay. All right, now you've got to use your negative exponent rule. These need to come down, and this needs to come down. X to the 0 is 1. And so we do get the same thing. So let's see. Oh, that should be 13. Okay. Clean up the inside using your rules of exponents. Take care of the outside exponent using the power to a power rule at the end. So if we clean up the inside, m squared over m to the 7. 7 is higher than 2. I subtract down here. N to the 4th over n squared. 4 is higher than 2. 4 minus 2 gives me 2. And now we use power to a power, power to a power. Here we are adding, and we add like terms, okay? And like terms are just like labels. So what are the terms in question? We got a u to the square, u to the first, and then a number. We do not have any more u squared terms, so that's 6u squared. We have negative 3u and negative 4u. Remember, when we're adding, we only affect the coefficients, negative 3 and negative 4. And then these are numbers, negative 7 plus 5 minus 2. All right, so we are multiplying a monomial times this binomial. So we're going to use our distributive property. So this is 6w to the 5th times 5w squared plus 6w to the 5th times 8w. So when we end up multiplying, we have to use our rules of exponents. So this is 6 times 5, w to the 5th, w squared, 6 times 8, w 5th times w to the 1st. 6 times 5 is 30. Multiplying the bases are alike. Keep the base, add the exponents. 6 times 8, 48. Multiplying the bases are alike. Keep the base, add the exponents. So this is negative 5u squared times everything in here. Okay? So is negative 5u squared times 2u cubed minus 5u squared times negative 8u squared minus 5u squared times negative 6u. Let's take a look at this. Notice that this negative 5u squared is multiplied times everything in here. Now, what's everything in here? 2u cubed. This is a negative 8u squared, so it's multiplied times that. This is a negative 6u. So negative 5u squared is multiplied times everything. So let me okay. All right, so now we have the roots of exponents and also multiplying with negative numbers. So a negative times a positive is a negative 10. This is u squared times u cubed. This is a negative, this is a negative. A negative times a negative is a positive. U squared times u squared. Negative times a negative is a plus. 30. U squared times u to the 1st. When multiplying with exponents and the bases are alike, you keep the base, add the exponents. 2 plus 3 gives me 5. 2 plus 2 gives me 4. 2 plus 1 gives me 3. So negative 10u to the 5th plus 40u to the 4th plus 30u cubed. All right. Now I always like this single term, this single monomial. I like to put mine in the front. And I'm going to use my distributive property. Negative 9ab to the 6th, 3a squared b cubed, 9ab to the 6th, negative 6a cubed. Okay, so this is distributed to everything on the inside. So a negative 9 times a positive 3 is negative 27. A to the 1st times a square is a cube. B to the 6th, b to the 5th. Keep the base, add the exponents. A negative times a negative is a positive. A to the 1st times a cube is a 4. B to the 6th, don't have another one. Now here we are multiplying two binomials, and I'm going to do this 3 ways. One, use the distributive property. Then I'm going to use FOIL, and then I'm going to use a vertical arrangement, and then actually you might do it 4 ways, okay? So what you do is take the parenthesis with the greatest number of terms, and that stays intact. In this particular case, we only have 2 in each one, so it doesn't matter. So I'm going to take W and multiply it times this parenthesis. Then I'm going to say plus, because that's what is right here. And then I'm going to say 2. So we say W times the parenthesis and 2 times the parenthesis. Okay. All right, and then I'm going to use the distributive property again. So W times W is W squared minus W times 4. So W squared minus 4W plus 2 times W is 2W minus 2 times 4, which is 8. Then we combine like terms, W squared minus 2W minus 8. Okay? W squared minus 2W minus 8. All right, let's do this problem again. W plus 2 times W minus 4. Okay? We have what we call FOIL. F stands for first. We multiply the first terms in the parentheses. These are the first terms right here. So W to the first times W to the first is W squared. O stands for outer. Okay, we multiply the outer terms. Okay. Now outer means outer. So this times this would be outer. O, the I stands for inner. This would be inner. 2 times W. And then L stands for last. We multiply the last terms in the parentheses. 2 times negative 4 minus 8. And then we combine these right here. So this is W squared minus 2W minus 8. So that's another way that we can multiply this. All right, so W plus 2, W minus 4. This is what a lot of students like. They like to do a little matrix. And they put this first term here, and then they put the plus 2 there. Put that term here, and then put the minus 4 here. And they use a little box. W times W is W squared. Okay? W times 2 is 2W. Minus 4 times W is minus 4W. Minus 4 times 2 is minus 8. And these you can add together. W squared minus 2W minus 8. So that might be something that you like. So either way that you want to do this, I'm going to use the little matrix. 3 and plus 2a, 5 and plus 7a. 3 times 5 is 15. 5 times 2a is 10a. 7a times 3 is 21a. 7a times 2a. 7 times 2, a times a. 7 times 2 is 14. A times a is a square. So this is 14a squared. So we have 15 plus 31a plus 14a squared. Typically, we put this in order from the highest exponent, so I need to turn this around. 14a squared plus 31a plus 15. Let's do this one. 5a minus b, 7a minus 5b. 7a times 5a is 35a squared. 7a times minus b is negative 7ab. Negative 5b times 5a, negative 25ab. Negative 5b times minus b is 5b squared. So this is 35a squared minus 32ab plus 5b squared. Okay. Now, this means that you do this twice. It doesn't mean 2 times 5a. It means you do it twice. So 5y negative 7, 5y negative 7. 5y times 5y is 25y squared. 5y times negative 7, negative 35y. Negative 7 times 5y is negative 35y. Negative 7 times negative 7 is 49. So 25y squared minus 70y plus 49. Now, let's take a look at this division problem. So we need to rewrite it like this. Now, to do this division problem, what we're going to do, we're going to pull this apart. We can only do this because these are pluses. If pluses and minus, I can pull it apart. So it's 36x cubed over 4x plus 12x squared over 4x plus 24x over 4x. And so 36 over 4, the number is 9, but I'm dividing, so with these variables, okay? So with variables, we don't divide the exponents. We have to subtract the exponent. 3 minus 1 is 2. 12 divided by 4 is 3. 2 minus 1 is 1. 24 divided by 4 is 6, and these x's cancel. I think there's one more. All right, let's do this last one. All right, 16 divided by 4 gives me 4. Now, these are rules of exponents I have to use. 7 minus 5 gives me 2 in the numerator. 5 minus 2 gives me 3 in the numerator. So I don't have anything left in my denominator. Okay, let's come over here. 20 divided by 4 gives me 5. But now look at this. The v to the 5th is in the denominator, is higher. 5 minus 1 is 4. 5 minus 2 gives me 3 in the numerator. So this is the answer for this problem. Okay. All right. I hope this helps, and I will talk to you later.